square. We got displacement. After you add all this together and this, you can get theta as well. So is any problem here?
Yep,
You sure?
it's good. Do either moments or energy. I don't mind.
So you want energy?
Yeah, sure.
So how about Newton's law and all of this? It's fine?
Yeah, I think those are fine. Like energy and like kinetic or like
Okay, so
something like that.
let's work on energy, okay? But all energy, okay? Look dear. First, energy, before energy, you have to get work, because work and energy, they together, okay? So we'll start with work, because work also equals the change in energy. Okay, so what is work? If I'm asking you what's the meaning of work, work, I have object, I use force to move it, so it make displacement. So to get work, work is the dot product. Teacher, what do you mean with dot product? Is force times displacement cosine theta. What is theta? The angle between force and displacement. And this is really important. Okay. Give example, right? To make it more clear. So now if I say I pull this object, which is a 20 kilogram, I pull it with force 200 Newton, and the angle is 30. And this is move like a displacement or distance, let's say 4 meters. So what is work? We're going to say easily, the total work is force times displacement cosine theta between F and D. What is the force here is 200. What the displacement is 4 cosine. What's the angle here between F and D? This is F and this is D. So the angle is 30. Okay, good. We got work. And what's the unit of work? Look at this. The first one, the unit of work is J, joule. But this is not a common. The most important one is SI unit for work, which is kilogram meter square per second square. Also, this is SI unit for energy. Okay? Good. Do you have any problem with this? I can't hear you. Do you have any problem?
No.
Good. Work is a scalar or vector. Work is a scalar quantity. It's not vector. Okay. We done this. So there's no any problem with work. According to Newton's second law and with dynamics, we know that work, kinetic, energy theorem. What is that? Which means total work equals the change. This is a triangle, is a change in kinetic energy. Oh, wait a second. What? I need to know before continue this, what is energy? Right? Energy in general is ability to do work, which means we understand how to get work. What's the meaning of work? Is force, make displacement, to make the object accelerate. Yeah, this is really important. So force to make the object accelerate. What do you mean with accelerate? Speed up, or slow down, or change direction. Once the force did one of this, make displacement, we call it work. So that's why we say energy is ability to do work. Okay, good. How many kinds of energy? We have many. But what's the most popular one? Start, kinetic energy. And that one is not quite popular like the second one. What is the second one? Is potential energy. What is the third one? Mechanical energy. Okay? Good. What is kinetic energy? Once the object has two things. So kinetic energy is energy due to motion, which means I need motion. And the formula is half mv squared. M, mass, v is velocity. And this is a good question. Can kinetic energy be negative? Yes or no? I'm asking you, kinetic energy can be negative?
Yes.
Amazing. Perfect. You're smart. Why?
Because it can go like anywhere.
No.
Oh.
Kinetic energy is half mass v squared. So v is velocity. So even mass, no negative, right? Velocity, it could be positive, it could be negative. But this is v squared, so half m. Negative v squared is still plus. So kinetic energy is impossible to be negative. Okay? Good. Why, teacher? Because v squared. And the second question is it a scalar or vector? All energy.
Vector.
All energies are scalar or vector?
Vector.
No, they are scalars. Okay? Why? Because in science, we just say it is impossible to be negative, but vectors need positive and negative, right? Good. So this is the first thing. Kinetic energy is half mv squared, and we can get it. Let's take a simple example, which is so easy. So if I have object with 4 kilograms, move with velocity, which is 40 meters per second. Find the kinetic energy. Find KE stand for kinetic energy. So we say half mv squared. Half times. The mass here is 4 times v squared is 40 squared. That's it. And the unit is J. Do you have any problem?
No.
Perfect. Continue. Let's go to the last part in kinetic energy, because potential energy is quite long, because Hooke's law. So look there. We have a law called work kinetic energy theorem. What is work kinetic energy theorem? Work kinetic energy theorem is work equal the change in kinetic energy, which we talked a little bit about it, just tried it. We wrote it. So what is work? Force time displacement. Vectors. Equal. What do